of Chapter 4 lecture. We're going to talk about how to name and write formulas of ionic compounds and then covalent compounds. There are certain rules that we have to follow, and once you learn the rules and do some practice problems, you'll get the hang of it in no time. The two things that we have to keep in mind is that nonmetals, all of the nonmetals, those elements that are in the upper right-hand corner of the periodic table have a single ionization state, which means that they will always form the same ion. Depending on the group, group 7 will always form a -1. Group 6, as we talked about, will always form a -2, and group 5, nitrogen and phosphorus, a -3. However, not all metals have a single ionization state. Some metals, such as those that are the majority of the transition metals, they form multiple ions. Iron, for example, could be an iron 2 or an iron 3. So a +2 or a +3. Copper could be a +1 or a +2. So not all metals form the same ion. Therefore, we have to make a distinction between those. If we want to name ions of metals that have a single ionization state, meaning they form just one type of ion, we first write the name of the metal because, as you know, the metal comes first in an ionic compound. And then we write the name of the nonmetal, we drop the ending, we cut it off, and we add IDE to name the anion. Calcium, for example, will always form a 2+ ion because it's found in group 2. You've got to remember these ions by group number. That will help you quite a bit. Calcium is +2, magnesium is +2. Zinc and nickel are two of those ions that, even though they're part of transition metals, they only form one type of ion. So they're exceptions to the transition metal bunch. So when we name these types of compounds, we write the name of the metal first, which is calcium. And then when we go to write the anion, instead of chlorine, we cut off the in ending and we add IDE. So we say chloride. I have made a YouTube video here so that you can watch how to write the names of these compounds. So let's move on. If we want to write compounds, so to name ionic compounds for those metals that are part of the transition metals and not the exceptions like zinc and nickel. So all of these metals form more than one ion. Then we have to write the name of the metal, just like we did for those that form only one ion. But the difference is that we have to specify the charge of the metal in Roman numerals. Why in Roman numerals? I don't know, but it has to be in Roman numerals, so review those. In parentheses behind the name of the metal. And then the naming of the anion, so the nonmetal, is the same as the one in the slide before. As you can see, for example, I have 2 oxides of iron here. I cannot just write iron oxide, oxygen, cut off the ending and add IDE. I can't do iron oxide for both of these because they're 2 different compounds. So there's a difference between these two. And the difference is because the iron appears as 2 different ions in these 2 compounds. To tell the difference, I have to specify the charge of the iron in each of these compounds. Same thing with manganese here. I have 3 different oxides. I have to specify the charge of the manganese, and that tells me which one of these compounds I'm talking about. Once again, I've made a video on how to do all of these, so watch that to get an idea of how to write names or how to name those compounds that have ions that form multiple or metals that form multiple ions. Let's keep going. Oops, I had one more. When we have compounds, ionic compounds that contain polyatomic ions, they are named the same as the monatomic ions. So we just name, if the ionic compound has a metal that only forms one type of ion, we name it as the name of the metal plus the name of the polyatomic ion. If we have a metal that forms several ions, we name the metal, specify the charge in Roman numerals, and then add the name of the polyatomic ion. Remember that the polyatomic ions, they're composed by atoms that are covalently bonded to each other, and the whole unit has an overall charge. Most of them are negative, but there's one positive one that we have talked about. Memorize the polyatomic ions. Memorize, memorize. I have also made a video here on how to write these ions. So make sure that you click on it and follow me along as how to name these compounds. Here's some more problems just to give you a little more practice. Okay, that concludes the part with the ionic compounds. Now let's talk about covalent compounds. How do we name covalent compounds? Covalent compounds are those compounds that are made of two nonmetals. Therefore, they're named slightly differently. They're named as the binary sequence with prefixes attached that show us the number of each element. What do I mean by that? So here's the rules for how to name binary covalent compounds. The name of the more metallic element, which is the one that is farther to the left or farther to the bottom of the periodic table, is first, meaning the one that is least electronegative. Okay, that would be how you would tell. That is the one that's listed first. And then the second element is truncated, and the IDE is added, just like we did for ionic compound. The second element in the ionic compound got the IDE ending. So oxygen became oxide, chlorine becomes chloride, fluorine becomes fluoride, etc., etc. Then each element will use a prefix to denote the subscript that is found by each element. Now, this is the exception. If the first element that's listed has a subscript of 1, actually doesn't appear, but we assume that is 1 because we don't write the subscript for 1 if we have only one atom. That corresponds to, so 1 corresponds to mono, and for the first element we do not use it, we skip it. We don't skip it for the second, so we can use mono for the second element, but not necessarily for the first. We don't use it for the first only. But then if the first element has any of these, so 2, 3, etc., etc., we will use these prefixes even with the first element. For the second element, all of these are used. It doesn't matter if it's 1, and we will use the mono for the second, but not for the first. If the mono results in a double O or an AO, especially when we talk about oxide, so monooxide, for example, 1 oxygen, monooxide, we will drop one of the O's and write it as monoxide with 1 O, just for ease of writing. Once again, learn these prefixes because without them you really cannot write the names of covalent compounds very well. Okay, and I also have examples. I've worked out a video here on how to name these compounds. Here's what I mean by the mono. Carbon here has a subscript of 1, even though we don't write it, but we assume that it's 1. So for carbon, we don't write monocarbon, we just will write carbon. But then the 2 here, we have to name the di. The 2 has the prefix di. So we would call it carbon di for 2 sulfurs, disulfide, because we have to truncate the sulfur and add the IDE ending. Watch these, how I name them, and if you have any questions, please ask. That concludes the part of the naming. The next part is going to be on Lewis dot structures and of molecular geometry.